කයිස මේ රෙකෝඩ් වෙනද? දැම්ම නම් මෙසේජ් එකක් දාන්න. Alicia. Hi. So yeah, as I said, I will be doing this in English. So before we start coding, there are certain things I need to clear up. So let's first of all talk about those. Uh, so okay, give me a minute, please. So okay. So yeah, before we start talking about developing the web server, we need to talk about some little technical things. So let's start with why computer networks exist. So why do they exist? So the main reason why computer networks exist is that uh, computers can communicate with each other. Communicate with each other. They can communicate with each other and share resources and information and many more. So that's the main reason why computer networks exist, right? So here's a description I got from Wikipedia, I guess. So no, this I got this much achieved. So what it so the basic uh, purpose is that we can share resources. That's all. So when it comes to sharing resources, there are two ways. Okay, so there are two architectures how we connect these computers. The first one is the peer-to-peer architecture. All right, so it's known as the P2P architecture, so it's peer-to-peer architecture. So in this architecture, every computer in the network can either receive or send data. So every computer has an equal or similar role. So the computer over here can ask for resources from this computer, and this computer can ask resources from other computers as well. So there aren't any specific roles. Everyone's like an equal in this network. And then moving on, the second one is client server architecture. So before talking about client server architecture, we need to talk about what is a server. So what is a server actually? So when we hear the word server, this is the first thing that comes into our mind, right? I mean, it's not wrong. These are these are computers that's uh, specialized in hosting servers, all right? But apart from this can also be a server, like the laptop you have right now. This can be a server. So can this. This is a Raspberry Pi. If you wonder what this is, this can be a server, and so can this. Yes, it's a microwave. So technically speaking, a microwave can be a server only if it can connect to a network. So most of the modern microwaves, have all those smart features and stuff. So technically speaking, if the microwave can connect to a network and if you can jailbreak into the firmware, you can host a small website. So you can host a small server. So then we have the question, what is a server? Like if all those computers can be a server, then what is a server? The server is it's actually uh, a special computer in the computer network that provide the resources to other computers that request them. So, so the definition I have provided over here says that server is a computer that provides information to other computers called clients on a computer network. So there's another thing called clients. So clients are these. Clients are all the computers that's connected to a server. So what happens is that the server manages the resource, the client makes a request, and the server provides the response based on the request. So every computer that's connected to the server is known as a client. So everything. So unlike in peer-to-peer architecture, here clients don't make requests to other clients asking for resources. So always the client makes a request to the server. All right. So there are many types of servers. There are display servers, there are database servers, and web servers. The one that we are trying to develop. So technically, server is something that provides a resource to clients. So clients, as shown in this image, clients are the computers that's connected to a server. So when it comes to web servers, so what we do is that we usually open up a browser and type a URL, and then we get a website, right? So what we do is that if you're like accessing a website that's hosted in a server, so what you do is that you type the URL like this. So what happens when you type the URL is that there's something called a domain name system. So what happens is that the URL gets converted into the IP address where the that particular website is hosted. So let's say that you want to access youtube.com. So YouTube is hosted in a server in India. So so computers connect using IP addresses. So I will go into IP addresses later in a Kuppi. So this Kuppi only focuses on developing the web server. All right. So I won't go in depth into some networking concepts in this Kuppi mainly because I will cover them in another one. So don't panic even if you don't understand. Okay, I'll try my best to cover them up later. So here what happens is that when you type a URL or a website name, the domain name system provides the IP address of the server where that website is hosted. Then your computer makes a request, or your computer gets connected to that server using the IP address. All right. So and so this is how things happen if you are accessing a website that's hosted in a server that's in an external server. But if you are accessing a website that's in your computer, all right. So we have some experience related to this from last semester's IWT course. So we all developed a website. So in that situation, in that scenario, what we did was that uh, we access the website using localhost. So one difference over here is that when you type the URL, that URL get converted into the IP address. But over here, what happens is that over here we define the IP address and the port. I will explain what port is later. So and then we tell which website we want to access. Over here we only specify the website. We don't say we want we don't specify the IP address or anything. But over here we specify the IP address. So localhost means this. Okay, so just in case if you don't know that. So the difference in this, so when you're accessing a website, you technically try to communicate with the computer that hosts that website. All right, so that's what we are doing over here. So one error that might occur when you are using localhost is that if this website isn't hosted in this location, then it's gonna result in an error where if you're using DNS, it's gonna give you the correct IP address all the time if the DNS is configured properly. So that's something you have to keep in mind when you're developing the website. Right? And then, so the last thing I want to talk about is what is IP address, port, and network interface. All right. So all of these are concepts, but that's concepts assigned to computer networks. So think of your computer as an apartment complex. Okay, so like this. Think of your computer as an apartment. All right. So the apartments have many rooms. All right. And in each room, there's a different occupant. Okay. Then they do different things in those rooms. Like different people live differently, right? Some might host a party, some might go to sleep early, some might be playing video games all night, different stuff. And each room has its own number. So the analogy is that the IP address is kind of like the address of the apartment complex, and the port number is like the room. So when I say localhost port 6969, what it specifically means is that uh, in my computer. Okay, so localhost means the computer the client computer itself. Okay, so in the computer, go to the room 6969, and in that room there should be this website. Access, return me, give me that website. So that's what it means. So that's what a port is. So there are many ports because there are many processes that happens in a computer, and in order to access that uh, process, you use the port number. And a network interface is like the entrance. So network interface is like the one that okay. So let's say that someone wants to send a letter to someone who lives in this apartment, room number 43. All right. So let's take that example. So what happens is that the letter gets posted into the letterbox of this apartment. So let's say that this apartment has a letterbox, and that then from that letterbox, that letter gets forwarded to the room. So that letterbox is kind of like the network interface. That's the entrance. The communication channels can enter the device, and so I hope that that's clear actually. So when you open up a terminal and type the command ifconfig, we did that in our first networking assignment. So when you type the command ifconfig, it will list out all the network interfaces. So there can be a network interface for the Wi-Fi card. There can be a network interface for the wired communications, and there's always going to be a network interface for the loopback. Loopback means that sending messages to yourself. And a small note: the IP address is actually assigned to the network interface, not to the device. Okay, so if a device has like three network interfaces and all those interfaces are connected to a network, it's gonna have three IP addresses for each network interface. All right. Uh, so those are certain things that you have to keep in mind when you're developing web server. Those are like I will go in depth and talk about them in later cookies. But right now I'm just skimming through them so that you have a general idea what it is. All right. And now let's talk about developing the web server. All right. So there are 5 steps when you're developing a web server. Okay. So as shown in this slide, you have to first of all create a socket and then bind the socket. Listen, you have to create this. You have to make that socket a listening socket, and then accept incoming requests and send a response. Okay, so I will go through each one of these steps one by one when we are developing the code. So don't panic. Okay, these are quite simple concepts. So so the first step is creating a socket. So what is a socket actually? So this is the definition I got from Wikipedia. So what it says is that a socket is one endpoint of two-way communication link between two programs running on the network. The socket mechanism provides a means of interface communication by establishing named contact points between which the communication takes place. Okay, that's quite big. All right, so let's take a step back. Let's try not to understand. Let's try not to go through this. And first of all, try to understand what is interprocess communication. So, what is interprocess communication? Interprocess communication is how processors that's running inside your computer communicate. So, at any given point of time, there are multiple processors running inside your computer. So you can check the running processors in your computer by pressing Control Shift and Escape. So again, let's try that one out. Okay, so I open up my task manager, and over here you can take a look at all the running processors over here. So there's hundreds of running processors at the moment. All right, background processors and many more. So these are all programs, okay, running in your computer, and these processors need to talk to each other. And interprocess communication is different types of ways these programs uh, used to communicate to each other. So there's this communication method. if I'm not mistaken, this one is known as pipe method. So what happens is that the process one sends a message to the kernel saying that it needs to talk to process two, and then the kernel forwards the message to process two. Another one is shared memory. So what happens here is that process one and process two read and write from a shared memory space. So that's another way of communicating. So both of these in both of these methods, the both processors has to be in the same device. Okay, so not only the both processors, if there's like hundreds and hundreds of processors involved, and if they're using this method, all the processors has to be in the same device. A socket is a inter-process communication method uh, that allows two processors that's in two separate devices to communicate with each other. So process one can be in computer one and process two can be in computer two. And using sockets, these two processors that's in two different computers can communicate with each other. All right. So those are the networking. So not networking, more like technical concepts. I need you all to be familiar with before we start. Before we get into the coding. So, are there any questions related to this stuff? If not, let's start the coding. So, yeah, are there any questions? All good? Uh, okay, if there aren't any questions, then I will move on to the coding. Okay, so just give me a moment. Okay, okay, you can see my screen, right? So yeah, I just noticed that I shared the Canva window instead of sharing the entire window. So yeah, let me show the task manager. So just in case if you aren't familiar with it. So this is task manager. It shows all the running processes. All right, you can see this, right? Yes, you can see that. So this is and these processes sometimes need to communicate with each other. So let's say that for an example, there is a antivirus program that needs to run uh, every 4 hours. So antivirus program doesn't keep track of time. Okay, so what it does is that it only check for any virus or any malware in your computer. So there's another scheduler program. So let's say that there's a scheduler program that keeps track of time and alarms any software that needs to be run in a specific time. So the scheduler program keeps track of time, and when 4 hours is up, it sends a message to the antivirus program saying 4 hours up. You should execute now. So like that, these processors need to communicate with each other. And as I said here, rockets are a method where processors that's not in the same device can communicate with each other. So if that's clear, then let's start the coding. So let's open up VS Code. So for this, you should have a Linux machine. It could be either a virtual machine or a dual booted one or a WSL like what I'm using right now. WSL also works fine. But somehow it has to be a Linux machine. So I don't think I have a directory for this. No? Okay, so let's start the code. Okay, let's name the server. Let's name the program server.c, so it's easier for you to understand. Server.c. Okay, so if you took a look at the code I gave you in WhatsApp or the one I posted, so one I shared in the Google Drive. you all might have seen like a lot of import statements. Okay, so let me open up the code I used quickly. So give me a moment. Uh, it's not the Kuppi one. This thing. Okay, so over here you can see like a lot of import statement, lot of header files included here. So the main reason for that is that like in the Z programs we are used to one or two header files provided all the functions we needed to create the program. So uh, in the last semester we all we needed was the stdio.h header file. All right. So include. Give me a moment. Include stdio.h. So this is the header file we are all familiar with. So this header file provided almost all the functions we needed to create a basic program in the last semester. And same thing with stdlib.h. It provides all the functions we need to create a simple dynamic memory allocation program. So in this scenario, the problem is that you need sometimes one of these header files only provide a one function or one macro or like very little functionality. Because of that, you need like a lot of header files to create this program. There's nothing like serious going on. The only reason is that unlike in our previous experiences where one header file provided all the functions we needed, in this program there are certain header files that only has like one use case have like one use case. That's why there's like multiple header files. So I'll explain each use case one by one. So let's start creating the program. So first of all, we are going to need the main function and return 0. So if we take a look at the steps we need to create the web server, the first step is to create a socket. All right. So in order to create a socket, you need the socket function. All right. So if we take a look at the socket function, you can. So this is a small tip I can provide you. All right. So if there's like a particular function, C function, you need to look up. If you're like aren't sure how it works, you can just use the man pages. The C functions are included in the man pages. So if you type man and the function you need to look up, it's gonna give you a general idea of what the function is, format and print data. So what printf does is formats and print data, and over here it provides all the descriptions and the arguments and stuff. Sometimes it might be a little bit hard to read, but not all the time. All right. So in the same way, to create a socket we need the socket function. All right. So let's uh, check the socket function first. So over here, this is the function prototype of the socket function. So what the function prototype is that we did this before, all right? So this is something we did in the last semester. Function prototype is something that uh, what do you say? It introduces the function to the program. So over here, and then I can create the implementation of the function like this: int x, int y, and then return x, sorry, x plus y. So over here, give me a moment. So over here, uh, what has happened is that I have created this function here, but over here this is the function prototype that introduces the function to the program. So I'm not gonna go and talk about what function prototypes are right now because to be honest, there's a lot to talk about, and I'm not gonna talk about these basic concepts that we talked about in the last semester right now. If you are unfamiliar, just do a simple ChatGPT search or maybe watch last semester's Kuppi. I won't be able I won't go in depth into these concepts that was covered in last semester because There's a lot to cover and very limited time frame. So looking at the function prototype of the socket function, you can see that it returns an integer and it takes three integers as an argument. All right. So I will talk about what these arguments are one by one. Okay. So let's first of all create an instance of the socket function. But before that, we need to include the header file, and the header file that has the socket function is this slash socket.h. So before using the socket function, you need to include that. So include this socket.h. You also need to include the this header file because it has some types you need to create the socket, and it has some types that's used by the functions in this header file. So because of that, you have to include the types.h file as well. So one other thing I have to point out is that, like, just because this one is prefixed by this sys and backward slash, don't think it's something that's quite hard. So what this means is that this header file contains functions that's used for system controls. So here we have this stdio.h. Okay, so over here the std part defines that it's standard input output. So std says that it's a standard header file. Same way, this means that it's a function used to function you for what do you say, for working with the system. All right. So yeah, don't think too much about this now. All right. So let's create the socket instance of the socket function. Create a listening socket. So I will explain what a listening socket later. You'll understand it later actually. So let's create one. So int listening socket is equal to socket. So okay, so I didn't pass the arguments yet. So over here I created a socket and declared a variable that will hold the return value of the socket. So over here, listening socket fd means listening socket file descriptor. A file descriptor is an integer uh, that the operating system used to refer to uh, an input output function. So there are like you will see file descriptors quite a lot throughout this code. So file descriptors are used as a reference for input output methods. So like sockets, pipes, or files or stuff like that. So that's what a file descriptor is. It's basically an integer that's used for reference. This name socket file this. So now let's pass the arguments. So over here, first of all, even though it says it's int, we are gonna pass the integer as a macro. So I hope you guys remember what a macro is. My macro is something like this. Okay, so define pi 3.1, so 3.145, 1415. I don't remember the other one. So this is a macro. All right. So instead of using 3.14, you can use pi like this. So this is a macro. So the same way, instead of providing like hard coded integer values, we use macros to provide the integer value to these functions. All right. Uh, so over here, so if we take a look at the uh, valid arguments, okay, so for the domain, there are quite a few. So you have AF Unix, AF INET, AF INET 6. So what domain is actually the address family used for this for this socket. All right. So address family defines the structure of the address. So if we use IP, so AFINet, which is used for IPv4. So if we use AFINet, the IP address is going to look like something like this. Okay, 192.168.1.1. So 1.2. So this is a IPv4 address. So if we include this, okay, AFINet, AFINet. So if we include that, the address is going to be like this. But if I use AFINet 6 instead of AFINet, it's going to be a IPv6 address. So if you are familiar with IPv6 addresses, let me show you a quick example. I can pick. So, I have IPv6 address. So here, so this is an IPv6 address. All right. So so if I use instead of AFINet, if I use AFINet 6, the structure of the IP addresses that's accepted by the socket should be in this format instead of IPv4. So that's what the first argument specifies. It is used to specify the address family, and when you specify the address family, you tell the structure of the address and the header files to include and stuff like that. All right. So which will be used by the socket for incoming connections. So after the domain, we have the type. So what is type here? So when when we are trying to connect two devices, there are two ways, mainly two ways you can connect. So let me take a moment to show this to you. So let's give me a moment. Okay, loading. Okay. Okay, so let's say, sorry, there is a computer network like this. Okay, so there's this. Okay, that didn't look right. So let's say that there's a computer network like this has. Okay, that's a computer. So like this, there's like many computers instead of one, instead of two. Okay, and then these computers are connected like this. So this is a computer network. Okay, then that didn't look right. The computer network, and there are connections like this as well. So it does look like that. So these two are connected. So this is a computer network. So let's say that this is C1, C1, and this is C2. So C1 needs to connect to C2. All right. So one way C1 can connect. Okay, so there are two connection methods, mainly two connection methods. So the first one is connection oriented. Okay, that doesn't look anything like what I want. Okay, so connection oriented. So okay, connect. Okay, so connection oriented. So what happens in a connection oriented service? Okay, so these are the two methods, the main two methods. Computer networks connect and share information. So in connection oriented method, what happens is that uh, before sending data, the computers define a path. Okay, so what over here? So let's say the C1 is going to connect to C2. So it defines this as the path it's going to connect to the C2 computer. So after defining the connection, so the data is shared as data packets. So after defining the path, the data packets shared through this defined path. Okay, so all the data packets take the same path. They don't go through any other path. Always use this one. So this one is known as connection oriented service. So connection oriented method. This is one way to uh, computers can get connected. Okay, this is one method, connection oriented. The other method is connectionless method. So in connectionless method, it's in the connectionless method, you don't define a path. So these packets can take whatever the route they like. So this packet will take this route, this packet will take this route, and this packet will take this route, and another packet might take this route. Okay, so the packets can take any route they like, and they will arrive to the destination not in order, and then there will be another program that will run to put them in order. So one advantage over this is that because it doesn't take time to define a path, uh, you can share data a lot more faster than a connection oriented method. So this is a connectionless method. Connectionless methods are usually faster than connection oriented methods because you don't spend time to define a path. You just throw your data packets, and hope that they reach the destination. One disadvantage is that you can't guarantee that all the data packets that sent by the sender will arrive at the destination because they are taking various paths. Some might get lost. In the connection oriented method, you can guarantee that all the packets will arrive at the host, will arrive to the destination. All right. So those are the two connection types out there. So main connection, two connection types. There are other connection types as well, but those are like the two ones that that's more commonly used. Okay. So that's what the second argument is about. So the second argument says type. So it's asking whether the socket should be a connection oriented socket or a connection less socket. So that's what it's asking. So are there any questions about this? Anyone with any questions? Anyone? Anything? Uh, okay, if there aren't any questions, then I will go on to the code. So over here, so if we take a look at the, you sure want to question? Yeah. So over here, so at the sample is after this. So this is the argument. So this is a macro as well. This is the argument I need to pass to the function as the second argument if I want a connection oriented service. So if you read this, it says provide sequence reliable two-way connection based on byte streams and out of band data transmission mechanism may be supported. So what it basically means is that it's going to define the path and going to send data over it. If you want like connectionless socket, then you should use stock dgram supports datagrams connectionless unreliable messages of fixed maximum length. So if you want a connectionless method, you should pass sock dgram to over here. Okay, so sock d. So if I pass sock dgram, now the socket is a connectionless socket. So it doesn't define a path before sending data. So because we are developing a web server, we need a connection oriented method because we need to guarantee that the all the data packets will arrive to the destination. If some data packets are missing, then we won't be able to process the data properly. Because of that, we need a connection oriented method. For that, we have to use sockstring. So now the server is a connection oriented one. All right. So apart from those two, you can see that there are the arguments as well. You can pass to this function. I won't talk about those right now. They are that important for this web server assignment. So SoftPro is provides raw networking protocol access. So we talked a little bit about this today morning actually. Before today's live as well. Some might have been around there. So that's it. And the third argument we need to pass is the protocol. So the protocol is so there are multiple protocols that we can use for each connection type. So for connection oriented services, there are multiple protocols we can use. For connection less protocols, there are multiple. So for connection less services, there are multiple protocols we can use. So over here we have to define the protocol uh, we have to use. So the protocols you can pass a integer, but these protocol macros are defined in a header file called include net I net dot in dot net I net I net dot in dot page. So what's the issue? Oh, so I think that it's gone. There we go. So okay, so instead of passing an integer value, now I can you pass a macro, which is easier to read actually. So if I want to use TCP protocol, all I have to say is IP proto, then TCP. All right. Now, uh, yeah. So, all right. So now for the connection, this socket will use the TCP protocol. Okay. So if you don't want to use the TCP protocol, and if you want to use like MTCP, I think that's MTCP. Or MPTCP. So this is another protocol you can use. So it's an advanced protocol that probably won't be covered during this module. I'm just showing you some examples. So this is another protocol you can use. All right. So but let's stick to the DCP because DCP is something that we are familiar with. So this is uh, so right now we have created a socket. So that's the first step. All right. So over here we have called the socket function, pass the values as macros instead of hard coding the integer values. We use macros to pass these values. So over here, okay, this should be a finite. Okay, so because we are using IPv4 addresses instead of IPv6, so it's a finite. So what I'm saying is that the addresses are going to belong to the a finite family. So a means address family. So if you have checked out some YouTube tutorials, some might have used PF as well instead of AF, which stands for protocol family. Both are the same thing actually these days. So AF finite. So what I'm saying is that it's gonna be belong to the IPv4 internet protocol. So the address is going to uh, look like an IPv4 address, something we are familiar with, and the header file is going to be included also get defined by this. And then we say that the socket is going to be a connection oriented socket, and over here we are saying that it should use the TCP protocol. Okay, so there's another protocol called UDP. UDP is used for connectionless services. So if I use UDP over here, it's going to result in an error. So I can put UDP like that, but that's going to result in an error because I'm saying that the socket should be connection oriented, but I'm defining a protocol that's used for connectionless services. So this one's going to result in an error. All right. So I'm just showing you guys what's possible. So over here, so we have created we have created a socket. So if you take a look at this, we have only written one line, but there are like three header files we have included. So that's what I'm saying. So the main reason why there are like so many header files is because that you are gonna need so many to create very little. That's why there are so many header files. But well, if you take a look at them, there's nothing much. So if you're like, if you feel intimidated or something after seeing so many header files, what I have to say is that don't be, because it's nothing. So we have created a socket here. So are there any questions? Anything? So everything's clear up to this point to everyone? No one's saying anything. Sounds like everything's good. Okay, if you guys have any questions, just let me know so that we can clear them up right away. So that I don't have like 100 messages in WhatsApp tomorrow morning or whenever you watch this. So okay, so we created a socket here. Okay, so this works perfectly fine. But now let's take a look at the return value. Yes, the return value is an integer. Okay, so it says it's an integer, but let's take a look at let's take a look at it. Let's take a look at it a little bit more. Okay, so here return value, it says on success a file descriptor for the new socket is returned. On error it returns -1. So that's quite important because we need to make sure that this socket function, this line, got executed properly. So if it doesn't get executed, then we have to stop the program, because without a socket you can't actually have a web server. So one thing you do is that you check sorry listening socket is less than 0. So what I'm doing over here is that if the socket function is unsuccessful, so if the socket function results in an error, it's going to return -1. So I'm checking whether the value that's returned by the socket function is -1. You can also use this as well, which is also valid. Okay, you can, that's what you prefer. So this is what I prefer. Okay. So if there's an error, so what you need to do is that you need to stop the program from being executed. So the exit function is defined in the stdlib.h file. Okay. So as you can see that you need like a lot of header files to write very little code. So you exit this, and what you do is that exit failure. So exit failure is another macro, right? So if you take a look at the exit function and exit, so it takes another integer which is status. So exit failure is a macro that's defined in the stdlib.h files. So and that value gets passed into this exit function. And if there's an error, if the uh, value that's returned by the socket function is less than 0, which is if the value returned by socket function is -1, then we stop the program from being executed any further, because it's not going to work. We need a socket. So if there isn't a socket, then there's no point of executing. So it's always a good practice to let whoever use this program know what went wrong before stopping the program. And I have to include stdio.h file for that. Okay, so it's always good practice to let know what happened. So socket failure. So it's just go with that socket failure, and so that's pretty much it. Okay, so this is the code for creating a socket. All right. So what we're doing is that we call the socket function, we pass the arguments that are required by it, and then we store the return value in this variable. We check whether the value of the variable is less than. So we check whether the value of the variable is -1 by checking whether it's less than 0. If it's less than 0, which means that the socket function didn't get executed properly, we print a message saying that the socket failed, and then we exit the program. Okay, so I hope everything's clear up to this one. So any questions? I don't see anyone. So if you guys have any questions, don't wait till I ask for questions. Just uh, open up your mic and ask, or drop me a message. All right. Uh, so if we go back to the code, so there's a couple of small improvements I need to make to this one. So over here we are explicitly saying use the TCP protocol. That's actually not necessary, because when you are using the when you are using a connection oriented service, the default protocol will always be TCP. So you can just pass 0. So by passing 0, what I'm telling the compiler to use the default protocol. Okay, so I'm not telling it to use TCP. What I'm saying is to use the default protocol, which is TCP. So I'm not explicitly saying use TCP. So over here, Sockstream is a connection oriented service. For connection oriented services, the default protocol is TCP. So I'm telling it to use the default protocol, which will be TCP. Another one I need to point out is that printf is mainly used to print messages into the terminal. But if you want to print an error message, there's a special function called p error. So in the p error, so what you can do is that so instead of using printf, you should use p error if you are printing an error message, because it's p error is specifically used to print error messages, and there are like some stuff that happens under the hood that is that's better for the code actually. So I will show what the difference between printf and p error when we have a basic web server. Right at the moment, it's not practical. Oh, I might be able. So okay, so let's comment this out, and let's have this one, and so let's try to compile this and execute this. So if you want to execute this, first of all you have to compile the server. So what you're doing is server.c. So this will give me a executable file called a.out. Okay, so this is the a.out. So this is an executable file, and it's not practical to oh shit. So I compiled without saving the file. So let's compile again. So this is an executable file, and even if you open it up, you won't be able to read anything. So yeah, oh, this is what an executable file looks like, and there's nothing you can read. So I get this executable file, and I can execute it using this command, and I don't get an output because obviously I'm not printing anything. So I can force an error by saying that I need to use the UDP protocol. IP proto. If I say UDP, this one will result in an error, because over here I'm saying use a connection oriented service, but I'm explicitly saying use a protocol that's used for connectionless services. So if I try to compile this and execute this one, it's gonna give this socket failure. All right. So that's what happened. So that message was printed by the printf, but if I use p error instead of printf, the output is different. Protocol not supported. So it gives another message telling, so explaining what went wrong. So let's play this out and do it again. Compile, and then if I try to execute this, so it's different from the error message you will get if you only use uh, printf. So if you use p error, it gives another message indicating what went wrong. Protocol not supported. So even if I don't have a message here, so even if I don't have a message, it still gives me a message, because there's some error handling not error handling, more like indicating the error that happens under the hood in a p error function. So it's always a good idea to use p error instead of printf when you're printing an error, because you have this you get a little bit more information. Right. Give me a second. So okay. So yeah. So this should be 0. Or if you like to explicitly define it, then you can use IP proto TCP. Absolutely no problem. That's your choice. But I like to leave it to the default protocol because it's easy. All right. So right now we have created we are done with the first step. So we created a socket. So we are done with the first one. So let me know if there are any questions or any area that's not clear. All right. So moving on, the second step what we have to do is bind the socket. So what is binding? So binding is so assigning an IP address and a port to this socket. So let's say that your device gets a message. Uh, so let's say, okay, let's go to the whiteboard again. Uh, so let's say that you in an apartment, okay, or let's say yeah you're in an apartment. Let's use black instead of red. Okay, so you're in an apartment like this. All right, so it has many rooms and stuff, and over here you put up a letterbox. Okay, so it's a letterbox. Okay, this is a letterbox. So just because you put up letterbox doesn't mean that you will receive the letters you get to this box, because you haven't specified the address that this address to who this letterbox belongs to. So let's say that the person who lives in room 4 put up this. So if I don't put up the address of the room of the person of the room where the letter should be forwarded to, uh, so no one knows what to do with this letterbox. It just sits there, so it's not connected to anything. So that's what binding is. So there's a socket. I created a socket, but I don't know uh, to which data to which so the operating system, actually the operating system doesn't know to which IP address and port this socket is assigned to. So okay, so let's say that there is uh, so the operating system gets a message to its IP address port 8000, but I haven't to, told the operating system that this is the socket that listens to port 8000. So the operating system doesn't know what to do with the packet it received, because I haven't told that this is the socket that is responsible for handling those packets. All right, is that part clear? Is the binding clear? So what binding does is that it tells that to the operating system this socket will be responsible for handling the data packets that gets into the particular port and the IP address. So is that clear? Any questions? Any questions related to binding? All good? Okay, if all good, then let's go talk about binding. Before talking about binding, I think I might have to revise what structures are. Okay, so in C you have basic data types. Okay, so you have integers, you have data types like int and then float, char, and then long. These are data types that comes with the program, like the default data types. But these data types aren't enough sometimes when you're creating a complex program. So you have to define your own data type. All right. For that, you use structures. So the way you create a structure is that you use the struct keyword, followed by the struct tag. We call this the struct tag. That's how you recognize a structure, followed by its members. So int x, int y. So this is how you create a structure, right? So I won't go in depth into this one as well, because this is something we did this last semester and it's not something that complex. So if I want to like create an instance of that data type, so what I usually do is that struct, oh, God, struct, and then use the structure tag, which is point, and then let's copy one. So that's the issue. Also, it's point, not print. Point. Okay. So what I did over here is that I created a new data type called point using struct, and then I created a new variable of that new data type. Okay. So this is what structures are. So so we need structures to define the address. All right. So I will explain what that means later in a bit. So before that, let's talk. Let's take a look at the bind function. Okay, so over here we have the bind function. Let's pull this up a little bit. So bind function defined in the socket.h file. So no more imports. The ones we have right now is enough. Okay, so this is the bind function. It also returns an integer. Okay, so the arguments it needs are the socket file descriptor, which is this. It needs the first argument. It needs the socket file descriptor. Then the memory address of the address, which we will do later, and the length of the address. Okay, so in order to define an address, so let's call it the address. So this address variable will hold all the information that's related to the address. All right, and the data type of that address is a structure. So it's a custom one, user defined one, which is defined in the this header file. Okay, net slash in.h. So the data type is struct doc, uh, right? So this is the data type. Address is the variable that will hold information about the IP address and port number and everything. This is the variable name, and the data type is this. Okay, hope this is clear, because this part can be a little bit confusing if you aren't familiar with structures. So that's what it is. Okay, and now I need to give the information about the IP address and the port to this address or to this variable. Okay, so what we do is the address, and then we specify the family. So like before, it's inet. So I'm saying that the address family is IPv4. So the IP address structure is going to be like what I said before. So everything I said before about inet, inet applies to this as well. So same thing I'm doing over here. I'm telling what type of address family it belongs to. Then I specify the port. Okay, so I specify the port, and the port should be provided in binary. So doing it like this won't work because it expects this value to be in binary. So for that, there's a function called htons. So and what you do is that you pass the value to the htons, and then it returns the that value in binary. So if you take a look at what htons is, so convert values between host and network bytecode. So that's htons function converts the unsigned short integer from net to net. So network bytecode is like, so network bytecode is different from the way we specify it. I don't exactly remember how to convert one manually. So over here we are saying 8080, but the way the network expects this is different. So that's handled by the htons, so we don't have to do it manually over here. Okay, so what htons does is that if you don't remember what htons does, so all you have to do is just you if you have Linux, you should have Linux. So man htons and scroll down a little bit. Then over here it specifies function converts the unsigned short integers. So
technically integers that can only have positive values, right? Unsigned means only have positive values. Short means that short values that. So integers usually have 4 bytes. Shorts have 2 bytes. So a positive integer values that with only 2 bytes. That's what this means. So it converts these integer values into the expected network byte order. So that's what it does. So hope that's clear. So over here, uh, I defined the address family and then the port, and then I need to define the interface it should be listening to. Okay. So I don't remember the one I choose for this. Give me a moment. Cat finance web server. Cat. No, sorry. What's the validation pass to this? Oh yeah, index. So I during the presentation I said that a computer can have multiple what network interfaces, right? So if you want your web server to listen to all the uh, network interfaces, you use this value. Okay. So an array any. So what I'm saying is, sorry. Okay. So over here, what I'm saying is that it should listen to all the network interfaces. So if you want to specify a specific interface, I will do that later because it's a little bit complex and it's uh, I think it will be a little bit too much for today. So over here, what I'm saying is that the this socket will listen to all the requests that comes from all the network interfaces. So if you don't want it to listen to all the network interfaces, then you can specify a specific interface. So if I go and type ifconfig here, ifconfig. So as you can see, that there's like 3 interfaces. So if I say in the array, it will listen to all these 3 interfaces. If I want it to only listen to F0, there's a way to specify it. I will do in another Kuppi because I will obviously have to do another Kuppi because I won't be covering optimization today. So yeah, I will. If you are interested in knowing that, I will explain that as well in that Kuppi, not today. Okay. So over here, I have defined the address in the address variable. Okay. And now what I need to do is I need to pass this to the uh, bind function. So bind status. So bind status is the variable that's used to hold the return value of the bind function. So this is the bind function. This is the function prototype. So it returns an integer and it will be so bind status will hold that value. Okay. So it will be bind. So the first argument it expects is the socket file descriptor, which is listening sockfd. Listening sockfd. So you can use the sockfd as well if that's what you like. I'm just being a little bit descriptive over here so you won't get any confused. You won't get confused. So the second one I need to pass is the memory address of the address variable. All right. The second one I need to pass is the address of the address variable, but the address should be casted into another pointer type. So I hope you'll remember casting. Okay, so we did casting in I did casting in the dynamic memory allocation part. So what it does is that it converts. So what casting does is uh, it tells the compiler to treat a particular integer. I manually say to treat in a different way. So I'll show you an example so you will remember, hopefully. stdio.h. So let's create a small program int return read 0. So let's create a value called x89 printf HSN x. So this is a small C program. So what I'm doing is uh, I created a variable called x, and then I'm going to print the value to the terminal. All right. So if I go gcc test.c hyphen node test, then I get the executable. So 89 gets printed. So what I can, so in casting, what I'm saying is, so even though x is an integer, I can tell the compiler to treat it as a float. So what happens right now is that even though x is an integer, this will be treated as float because I have casted it to a float, and as you can see, this format specifier is f instead of d. So f is the format specifier used for floats. So if I compile it again and run it, now you can see 89 is being treated as a float. Okay, in here it was an integer, over here it's a float. So that's what casting is. So in casting, you uh, tell the compiler to treat it like a different data type. So you kind of it's not like you convert, you change the data type. You tell the compiler, even though this value belongs to this data type, I want you to treat it as another data type. So that's what casting is. All right. So the same thing has to be applied over here. So at the moment, the data type of memory address of address is okay. So struct. So, so this is the data type at the moment of this. So so this is the variable data, right? So basically, when it comes to the address, so what happens is that you put an asterisk in between. So so this is the data type of the memory right now. But if we take a look at the function definition, it expects it to be in this data type. So it's a little bit different. So if you can recognize it over here, it's struct sockadder underscore in asterisk. The expected data type is struct sockadder asterisk. So that in part has to go. So what I'm going to do is I'm going to cast this into the expected data type. Okay, that didn't go right. So I'm gonna cast this to the expected data type, which is sock that, and now it's correct. So now I'm explicitly casting it to this data type, even though it belongs to a different data type. All right, and then the next one I need to provide is the length, the size of the address. So let's put it in another variable, address length. Let's call it address length, and then called size of function. So I hope you'll know what size of function is. Size of address, and then I need to pass the uh, address length. Okay, so let's call it ADDR length. So it's otherwise it's a little bit confusing. But not the one I wanted. Address length. Okay, address length. So okay, so you can pass the values like this. So if you notice one thing, okay, address length over here, the data type is an integer, but the accepted data type is socklen t. Okay, so one thing you can do is that you can cast this one as well. Socklen t. Where did that go? So you can cast this as well. But this part is actually not necessary because the compiler automatically converts this into socklenty, so you can just pass the integer and it won't be a problem. All right. If you want to, you can explicitly cast it, but that's actually not necessary. All right. So this is binding. Then again, we need to check the return value. So return value on success 0 is returned, on error -1 is returned. So if there's an error, we need to know that. So what we do is that we check if find status is less than 0, which means that it returned -1. The same thing I did with the socket. What I'm gonna do is p error. I'm gonna say find error. Sorry, find error expression. Then I'm gonna exit the program with the error code exit failure. Exit failure. Uh, so that's it for binding. Okay. So over here I went over a little bit of complex. I would say complex. It's more like a little bit something that's not we are familiar with. So over here, what we are doing over here is that defining the address. Okay, and then over here we bind the socket to the address. So that's what we did in these two steps. Okay, that now we have finished the second step as well. So any questions? If you have, just let me know. Uh, so did you understand everything? I'm quite surprised not going. Uh, so no questions? Nothing? Okay, it's 10 now. Well, yeah. One thing is that if this takes like a really long time, then I'm gonna stop with the basic server and then I will do the second part tomorrow because the second part there's like quite a bit of advanced C programming going on, and so if you take a look at this, so yeah, it might take some time. Because of that, I might not be able to cover the uh, uh, the complete web server today, but we'll definitely finish the basic one. All right. So now we are done with the binding. All right. So we finished the second one as well. Now the third step, we have to listen. So what is listening? So listening is listen. Listen. So let's go with listen. So what listening is? So let's take a look at the function. So you might get a better idea. So if you got listen, listen marks the socket referred by the sockfd as passive socket. That is a socket that will be used to accept incoming connection request using accept to. So what that means is that this socket will be used to listen to a connection request. Okay, so when we are connecting the two devices, first of all, the client device need to make a connection request to the server. Then the client device need to send a so in in this web server scenario, the client device need to send a HTTP request requesting the uh, source it needs. So before sending the HTTP request, it needs to send a connection request. So what the listen function will do is that it will convert this socket into a listening socket that will listen to connection request. Okay, so the listening socket only listen to connection request. I will talk about the other socket later. So there are two sockets involved when we are sharing data. The one is the listening socket which we have created here. So the listen function is the one that converts any socket into a listening socket. All right. So if you take a look at the function definition, function prototype, it also returns an integer. It needs so I need to pass the socket file descriptor and the backlog.
Backlog is the size of the queue. Okay, so just keep in mind backlog is the size of the queue. I will explain it later when we go to connection sockets. So listen, what we do is that we create a variable to hold the value that's returned by the listen function. So listen status is equal to listen function. For that, I pass listen sock file descriptor, and then usually the size of the backlog is 5. Okay, so if listen status is, so let's take a look at the return value. Return value on success 0 is returned, on error -1 is returned. So again, less than 0. Same thing we did before. Error listening error \n, and then you exit the program using this line. So that's pretty much it for listening. All right. So what? So I hope what listening function does is clear. So what it converts the socket. It assigns a. So there's this socket. It doesn't have a job to do. Like it's a socket. The listen function tells the socket your job is to listen to any incoming connection request. Okay, there are other types of requests as well involved in this web server, which I will talk later. So in the listen function explicitly tells this socket listening sockfd that your job is to listen to connection requests. All right. So uh, that's the listening part. Then we have the accept and receiving and stuff like that. Before that, should we take like a 5 minute break or something? Ravindu? ඕකන නට භක් වෙක්ක ගමුද චක්කේ නිදි නෑනේ කට්ටිය නිදිද
නෑ නෑ
හරි එහෙනම් මේ විනාඩි භාගකට බ්‍රේක් එකක් ගමු මේ ආයි එන්න 10යි 13ට okay so 5 minute break 5 minute 10:40 so let's start okay let me share my screen quickly so okay you can see my screen right so yeah that's good hopefully so okay so now we created so now we have a listing socket so okay, we gave it a job actually that's what we did so now what we need to do is that once it has a connection it needs to create another socket to share data so this is what happens uh, in the web server so what happens is so let's say okay let's say that's not long enough let's say this is the server okay and that's not nice oh. Okay so this is the server all right it has a listening socket oh god what's that so it has a listening socket okay the one we created
So what this one does is that its only job is to listen to any uh, connection request. So let's say that there is a computer here, so that wants to connect to this server. So it sends a connection request. Okay. So because we are using TCP in our particular web server, the TCP three-way handshake is going to happen. So I will explain what TCP three-way handshake is in an upcoming Kuppi. Okay. So what happens is that this one is listening to any connection request, and once there's an established connection request, that connection request gets queued. Okay, so it's put into a queue. Put it put into a queue. All right. So let's say that there are connection requests like this, and for each connection request, it creates another socket. Okay, and the application specific communication happens through this connection. So all the HTTP requests and the responses come and go through this socket. The socket we created, its only responsibility is to listen to connection requests and establish a secure connection between the one that made the request. Once there's a request, uh, there will be another socket that's used to send the data between the device that made the request. So the main purpose of this is it's like this one acts as a receptionist. So let's say uh, you go to an office to get something done. All right. So you go there and then you meet the receptionist. And instead of receptionist directing you to someone who can do the job, what would happen if the receptionist did the job by her or himself? Okay, so let's say that you go to a job, you go to an office to get something done. So the receptionist goes with you to do the work. So if someone comes in between that comes while you and the receptionist attending your matter, if someone comes to the office because there's no receptionist, the person who came after you won't be able to access the service. So the same thing happens over here. So if the so so this device makes a connection. So this device makes a request, and if this socket tries to send response to if this socket tries to listen to other request and then send responses, then this web server will miss out on any other request made by other computers. Because of that, this socket is only responsible for its all responsibility is to listen to connection request, and it puts them in the queue. The size of the queue is defined by the value we put here. So the size of the queue is defined by the value we put here. So right now the size of the queue is 5. So we can put whatever the value you want, but it's usually 5. Okay, so it's defined over here, and once it's in the queue, and one connection at a time gets taken out from the queue, a new socket is created, and it get connected to the device that made the request. All right, so that's what happens over here. So that's why I use the name listening socket FD for this one. Okay, so right after this, so when we are accepting, so the accept function returns the connection socket FD. All right, so I hope that's clear. So if there's anyone who has like some trouble understanding what I said, just uh, let me know right now. Anyone? So hopefully you guys understood what I said. So listening socket is only responsibility is to listen to incoming connection requests. So once a connection is established, so once there's a if a connection is established, it should listen to HTTP requests. All right, because the listening socket only listen to uh, connection request, but the client needs to send a HTTP request as well. So that is handled by the connection function. The it's known as the uh, connection function. So if I go and is connect or connect, I think it's connect. Yeah. So here you go. Initiate a connection socket. So that what this does is that it creates a connection socket. So uh, what I can do is that it also returns an integer. Okay. So let's create an integer int on sock. Sorry, sock fd is equal to connect. All right. So what happens right now is that I have created a connection. So connect function creates a connection socket that will listen to application specific request. So in this case, it will be a HTTP request. So the arguments you need to pass are the socket sockfd. So sockfd means the listening socket. Okay, and then you need to pass the memory address of the address variable, but you need to cast it into this data type. Okay, so again, sorry, struct. So, okay, and then you pass the memory address of the address, and for this function you need the and for this function you pass the address length. Okay, just give me a quick check. Oh, sorry. So I used the wrong function here. Sorry, guys. Not the connect function. It should be accept function. Yeah, it should be accept function. So accepts the connection socket. So this is the one used. Again, not the connection function, not the connect function. I got it wrong there. So so what it does is what I said. All right. So it creates a socket that accepts the request, and then the response is also sent via that socket. All right. So the same thing. So it's called a connection socket somehow. System call used with connection based socket type. So that's called connection socket b is equal to accept. So I need to pass the file descriptor listening socket b, and then this need to be casted. Struct so add type address, and one change is that instead of passing the variable for the address length, you need to pass the memory address of the address length. And then there are flags. We don't have any flags, so set to 0. What's the issue? Too many arguments. Oh, sorry. I accept doesn't have flags. Sorry. Small mistake. Okay. So this is the function prototype. All right. So the same thing over here. This is the one I shared with you uh, in WhatsApp. So this is the code I shared with you. So same thing done over here. So if you take a look at the return value, on success, the system call return file descriptor for the accepted socket. On error, -1 is returned. So same thing. We check whether it's less than 0, and if it's less than 0,
we say, what is it? Accept error, let's call it accept error, and then exit failure. So basically, what we did in before instance as well. So one thing here is that it's usually good practice to tell that the server is running now. Server is listening this port. So what's the port we used over here? So we used 8080. So we can say port is listening on port 8080. So and now, so this is, I explain what this is. So over here we create another socket that accepts incoming requests. All right. Then we need to create a buffer. So buffer is basically an array that will that we will use to store the request. So let's create that. Let's call it request buffer, and then let's define a buffer size of 4096, something like that. So one thing you can do is that you can use a macro for this instead of hard coding the value, because it will be used quite frequently. Define buffer size. Let's call it 4096. So technically, it's 4 kilobytes. Okay, so uh, it's not in. So 4000 bytes is 4 kilobytes. So over here, I can use the buffer size instead of hard coding the value. And what I'm going to do is that I'm going to say the first value is null character. So what this does is that I'm telling that all the values should be initialized to this. So this is known as the null character, if I'm not mistaken. So that's one way of indicating that it's an empty buffer. Otherwise, it will be sometimes filled with garbage values, which will result in what unexpected behavior. All right, and then the function we use to read the request from the connection socket to the buffer is called recv. All right, so this is the one. So what we can do over here is that it also returns a value in size d. You can use an integer if you like. You can use size d as well, no problem. All right, so over here I have used an int, and you can use an int or SIC. It won't be a big difference because they get converted automatically. It might be misleading sometimes if you're like making a really big program, then it might be a little bit misleading, but since this is a quite small program, it won't be a problem, right? So what we can do is that int, sorry, so this one will hold the value. So let's say read status should be req. So need to pass the file descriptor. So for this one, I use the connection socket, and then the buffer that this thing need to be read to, and the amount that need to be read to. So I need the entire buffer size minus one. You'll see why it's minus one later, and then I don't have any flags. All right, and again, if read status is less than zero, it has to be then. So it's the same thing most of the time actually. So return value. This return call return the number of bytes received if minus one error occurred. So basically same thing. So well, instead of like repeating the same thing, I can like, copy and paste it there as well. So what I can say is that error reading request.
All right. So now, so what I did over here is that the require function takes any request that was received by this connection socket, which was defined by the accept function, and then copies that request into this request buffer. Okay, so it's always a good practice. So to uh, define the last element of this as null character. So I'm not so sure whether you're familiar with this concept. So okay, so let me. I don't. So I'm not so sure that whether all of you all know how a string is stored. So let's. So this is a small example. So let's say there is a string called hello. So this is how you usually do it with printf. That's the same. And then hello. So and if I like try to compile this and execute, it's gonna say hello. Okay, so this is one way of storing hello. So this is the high level way of storing a string. So but we know that a string is basically an array of characters. So technically I can write this hello 2, let's call it hello 2. Instead of writing it like this, I can basically write it like this. That should be hello. So both of these do the same thing. So so now I'm so now let's bring both of them. So it makes sense. F1 by 2. Okay, fine, let's do. Okay, so if I print this, compile and print this, both of them gonna print hello. So even though like when we store a string, it's we write it like this. This is what actually happens. So this is what actually happens under the hood. So so this one is a lot easier to write actually. So if you so how hard it goes to write a string like this, this one is a lot easier. Okay, so and so the string we over here is stored uh, in an array. So each character is stored in an array, and the last element of this array is this character, which is I think it's called the null terminator. So it indicates the end of a string array. So that's what it used to. So in here, so what we are doing is after copying the request in the request buffer, I'm going to manually say the last character should be a null terminator. So just in case. So most of the time it's handled by the function, but just in case, I'm explicitly saying that so that there won't be any unintended behavior later. So I hope you guys understand why this is buffer size -1, right? So if there's like uh, 4,900, sorry, 4,096 elements, so arrays are zero based. So the last elements address, so last elements uh, index should be 4,095. So that's why we use -1. All right. So one thing I can do right now is I can, if I want to, I can print this request into the terminal request buffer. All right. So let's give a little test drive and see how it will turn out to be served. Let's see. Everything's good so far. I dot out. Okay, this one did not execute. Why is that?
Let's see. Let's send a small request and see how it's gonna act. So, this one's running in port 8080, right? Yes, running port 8080. So let's go over here and say localhost port 8080. Let's see how what's gonna go. Oh yeah, we got this. So okay, small issue. Where is it? Let's remove this one. This one's making this a little bit confusing for now. So let's remove that port is listening in thing. Might not be able to see it right now. Yeah. So yeah, we got this error right now. Okay. So what it's saying is that binder address is already in use. So what happens is that you will encounter this error quite frequently when you're developing your application. So what happens is that we executed the program once, and when we executed that, we used the port 8080, and then the program got terminated. But the operating system hasn't released the port 8088, so it's still in use. That's why when I try to execute, I get this error address already in use because the operating system hasn't released it already. So you will have to wait a couple of minutes until the operating system releases it. Okay. So if you encounter that error, just yeah, kill your time for like a couple of minutes, and then it will be done. So yeah, we had the request before. So unable to send. So this error happens because we are not sending a response. Right. So let's first of all let's try to execute this. I think we waited enough. Oh yeah, we have waited enough. So let's make a request. Localhost 8080. Let's say that I want to access abc.com. So I send the request, and so this is okay. I'm not so sure. Oh, I didn't compile. Might have to wait again. So yeah, small error from me. I didn't compile. So I executed the previous one. So this part. Okay. So starting from this get, this is the HTTP request. This is the request that got sent by the browser. All right. You have to ignore this part. Okay. Yeah. I might have to wait a little bit moment until we get to run execute the program again. So this is the HTTP request. All right. So it specifies what we want to do. Get. So this is the method, HTTP methods. Okay, I will go through all the methods later. So what these methods specifies that what the client needs to do with the server. So the client can access data that's in a server, or it can update data, it can add new data to the server, or it can delete data. So this method is used to specify what the client want to do with the server. Okay, so if it means get, it means that the client want to oh yeah, it's okay. So the client want to access this website. So let's run this. Okay, let's do this again. Okay, if I send a request again. Okay, okay, here we go. So this is a proper HTTP request. So over here, what we're doing is that we receive the request. Okay, so let's go through this code one by one. We created a socket, listening socket. Okay, and then we defined the address. We binded the address to the socket. Then we told the socket that it's going to be listening to any connection request, and then we created a connection socket that will listen to any HTTP request, and then we got a HTTP request, and then we copied it to the request buffer. Okay, and then we printed what the content that's in the request buffer, which ended up being the HTTP request. Okay, so this is the HTTP request. So get the method, the resource it's requesting, the HTTP version, host, and then the connection keep live, which means that a connection oriented one, and there are some other stuff as well. Okay, so the uh, accept type. So I will talk about this as well. So like when you're sending a response, there are file types
the client accepts. So over here it says that it accepts text-based HTML, and I think this is XML. Yeah. So this is, so if you haven't seen an HTTP request, this is one. All right. So we have gotten the request. Now what we need to do is we need to uh, send a response to this. So because this is a basic server, uh, we can provide the same web. We can forward the same response to all requests. All right. So we won't be passing or processing the request. So we accept the request. We don't process the request. We just send the response. So let's say this is uh, call it basic response. It's one basic response, and then we load it up. Okay. So I created a small HTML file over here. Okay. So this will be our response. So this is the one we will send to the web browser as the response to the request. All right. So now what we need to do is that we need to open this file. So it's gonna, so the function we use is open. Okay, so the open is defined in a different header file. If I'm not mistaken, let's call man open. So it doesn't work that way. So man open is defined in, I don't remember the function name. So it's actually this thing. So the open function is uh, defined in this header file. All right. So what we do is that it takes two arguments. Uh, First one is the path to the file we want to open. So it's going to be index.html, and the second one is going to be what we want to do. So it's going to be, if I'm not mistaken, it's ORB. Yeah. So what O, so what this means is that we are only going to read it. Okay, so it's going to be read only. All right. So we open the file. All right. Now what we need to do is that, okay, so first of all, one thing we need to check whether we were able to create the file. Okay, so now we were able to open the file properly. Same thing, if it returns -1, that means we weren't able to. So here opening file, let's say exit value. So all right. uh, So over here, we open the file and we check whether we were able to open it properly. And then now we create a header. All right. Header, we have to construct a header on our own. All right. So the first thing is, because we are sending a valid response. All right. So, mhm, yeah. Okay. Now, before going to this, I might have to tell you guys about what the compile time string concatenation. Okay, so it's a new concept that probably most of you all aren't familiar with. So let's say that there's a message called hello. Okay, so we can say what we usually do is hello world, okay, and then you print it.
like this. Yes, then sorry, that should be S. Hello. Okay, sorry. And then you can basically see test. Let's see how it goes. Test. And then if you execute this, it's obviously going to say hello world. So one thing is that you can write hello world like this as well. So what happens over here is that this will execute the same way. So my formatter does some funny thing. So if I compile this and execute this, it returns the same value. So this one's known as compile time string concatenation. So what happens is that even though like these two are in two separate within two separate double apostrophes, I think that's what we call this thing. Uh, they get concatenated. Concatenated means that they get put together. All right. So like if you have like a really long line of string, instead of like putting all of them in one uh, within one pair of quotes, you can put them inside multiple pair of quotes and have the same result. So even if I compile and execute, it gives the same result. So this is known as compile time string concatenation. If you're interested, you can look it up. All right. So that's what we are going to use when we are developing a HTTP response header. So over here we have to create a header. All right. The first thing we have to specify is the HTTP version. So it's going to be 1.1 because if you can remember, in our request it used HTTP 1.1, which is the HTTP version. So we have to use the same version, and there are HTTP status codes. All right. I will go through all of them in a later Kuppi, but 200 means that the requested resource was found. So some of you might be familiar with the 404 error. All right. What that means is that the requested uh, resource was not found. So if we go to the VLE, okay, then again, then okay. So right now I'm going to request a resource, and then what I'm going to do is that I'm going to request a resource that doesn't exist. So like this. So and then okay, what happened there? So okay, it has some error handle. So this one doesn't give me the error. So there are some sites that give you the 404 error. Okay, so that some of you might be familiar with that. So that 404 error happens when the requested resource is not found within the server. Okay, so because we are not like we are checking whether the requested response exists or not, we are just gonna hard code the 200 over here. Okay, so when you are doing error checking, uh, which was one of the requirements for the web server, I will talk about those in that one, but for the basic server we don't need that. So and so this is the first line of our header. Okay, and each line should be finished with backspace n and backspace n, otherwise it won't work. All right. So this is the first line. Then I don't know, one second. Give me a moment. I content type and content connection content type. So now I need to tell the client that type of content I'm sending it. Content type, which is text-based HTML. Again, backspace R, backspace in, and then the connection. Connection is closed after this. Because this is the last line of the header, you have four of these. So backspace n, backspace R, backspace oh sorry, backspace N, backspace R, backspace N. N.
So over here we have constructed a small HTTP header. All right. So now we need to send this back to the
Browser. So for that we use the function called send. Okay. So let's check it out here and send. So it's also included in the socket.h header file. So send also returns a value. Okay, it actually doesn't matter. Oh, small issue here. Oh no, I'll check them out later. So if you want to hold the value, send that you can do something like this, but we won't be checking it actually in this scenario. But you can if you want to. So over here we specify the connection socket and then the buffer. So buffer is basically the header file we want to send. The size is the size of the buffer, and we don't have any flags. So because we don't have flags, we use 0. So what this does is that this sends this header to the browser. Okay, so to whatever the client that made this request, and this sends only the header. Okay, in an HTTP response. Okay, let me show you the structure of an HTTP response. I forgot to show you that. So HTTP response. So okay, so you go. So this is the structure of the HTTP response. So status line, you specify the HTTP version, the HTTP code, and a small message. And then there are a bunch of key value pairs which specify the some content. You don't need to include all of them, but there are some stuff that you must include, like the content type and connection closed. So these whether this content type and connection closed or open depending on uh, the type of connection. So in this scenario, it's always going to be closed. Okay, but it doesn't have to be closed in every scenario. In our web server, it is closed. Okay, otherwise you might mix it up. So these are the stuff you need to include, and then there's the body. Okay, so over here we have only included the status line and a couple of key value pairs from the header, and we send the header to the browser, but we also need to send the body. So for that we use the send file function, and send file function is defined in I don't give me one send file. Please send file dot text. Yeah. So in order to send the file, you need uh, another header file, which is this send file dot text. All right, and you can once you have send file, so it over here which says so output file descriptor is the connection, input file descriptor is the excuse me open directory, and then the offset we don't have an offset, and then the amount, the size of the file we want to send, we usually go with the buffer size because it's a small one. All right, and that's pretty much it. All right, so this should send a response back to this server. Let's check it out. Okay, not wrong one. So let's go and compile this. Let's see, a dot out. Okay, and then let's make a request.
So it's the same one. Okay, now let's create new one. So let's see what it gets. Localhost 8080 abc.com. I sent a response and I got a response, but there's an error. So let's see what's wrong. So that's basically what's happening, right? Oh, I didn't close these things though. So yeah, yeah, you get the general idea, right? So what happens? So let's see what happened. What did I miss? I think I'm over here instead of save it should be now maybe. Let's check it out now. Not so sure. That's still taking time. So let's wait a little bit. Oh, I didn't. And there's another thing I forgot to do, which is that the uh, uh, this connection has to be closed. Okay, so once we are done with the done with working with it, we are going to close it. So the close function is in the in a header file called unist.h. All right, and so over here, what you are going to do is that you are going to close. So it's kind of like freeing the memory. So not it's not basically freeing the memory. What you are doing is that you are saying that you are done working with that particular resource, and you can. So what I'm doing is that I'm releasing it from the program. So you won't use. So you won't use it. So it's unnecessary. It's not very efficient. So let's give it a try again. Yes. Okay. Now it's better than the last time. Still getting an error, and I'm not so sure why. Let's see why. Let no, I need to close the other forget password. So let's take a look at this one. What's the issue? HTTPS. I think that's no HTTP. Control network content. That's HTTP. Given range.
Hi, there you go. So yeah, small error. So over here instead of HTTP, I had used uh, HTTPS. So yeah, that's why what happened actually. So yeah, so yeah, we are yeah. So the basic web service done. Yeah, a little bit of anticlimax, but yeah. So that's what happened over here. So if I go through the code one by one again, so you guys are here, right? Not sleeping. We still have got some people. So what happened is uh, from the accept function, I created a connection socket. All right. So that all the HTTP related connection happens through that connection socket, not through that uh, what the listening socket. So we created a new socket for that, and then we copied the request we received to this request buffer. All right. And then uh, over here we opened this file, so that's what we did, and then we created a header, and then we sent that header and the file to the browser. So that's basically after sending, you close all the file descriptors, so all the files, or more like they aren't files, they are more like input output methods, so that you stop using them. All right, so that's pretty much it. So if there's one thing that needs to be changed, that is that. So if you had no, if you had noticed, so this program stops be executing the moment it sends one response. So usually web servers can send as much responses as possible, like they keep executing. So one change we can do is uh, create a while loop. So infinite we create a infinite while loop. So this only stops executing when you terminate the program. So this way, you can send as much request as you like, and you always get a response. So let's compile and execute, and then let's go to this website. Okay, let's make a new another response. Localhost 88abc.com. Let's call b dot sorry. Then say abc.html. So this is a completely new request. I get the same response. Correct. So I get the same response. So let's make a different one instead of like sorry. So instead of saying log abc.com, let's say example.com, then index.html. So you get the same response. So that's the basic web server. All right. So what happens? So yeah, the program doesn't get terminated after providing the response because we are using a while loop. If we did we use the while loop, then it would get the program would stop executing the moment it sends a response. All right. So that's pretty much it for the basic web server, and the time is 11. I don't think there will be enough time to go through other stuff today. I will probably go through them tomorrow. So there are some changes I need to make. A little bit of optimizations here and there. Not optimizations, more like best practices. I will go through them tomorrow. All right. So this is the basic web server. So yeah, as I showed over here, so this is what happens. We created a socket. We binded that socket to an IP address and a port, and then we made a listen socket. We accepted. So in the accept, what happened? What happens is that we create another new socket, and through that new socket we get an HTTP request. And in this basic web server scenario, we don't actually process that request, but if we are like if we need to like send the accurate response, then we have to process the request we get. So in this scenario, we didn't process the request, and then we got the request, and then we opened a file we want to send, and then we created a header. We send the header and then send the file. Then closed every resource that we don't use. So that's the basic web server. So do you guys have any questions? Anyone? Anything? Right now, go again. So you guys can say anything if you want. Mock again, they got it.
මේ නිදි නෑනේ කට්ටිය. රයිදෝ ගනිදිද?
ඉන්න
තේරුණාද කිව්ව ටික?
මොකද්ද
තේරුණාද ඔබ කිව්ව ටික?
තියන්නේ මම කනෙක්ෂන් අවුලක් දාන්න
නෑ මම තේරුණාද කියලා.
හරි ෂේප් අවුලක් නැහැ.
තියනවා අය බලන්න වෙනවා මත් වෙනවට ෂේප්
Oh, may okay, Kohamat may. So yeah, one thing I have to say is that you won't understand it straight away. You have to like do the code, like code it, and then understand it by yourself. So it's better that you start as soon as possible rather than waiting for the last moment. So even though I explained what happens, you might have to spend a little bit of time doing this by on your own. Uh, so yeah, like I can like take time and explain, but still even then you won't understand because you need to do this a little bit. Uh, so yeah, I will do the other bit tomorrow, and that's pretty much it. Naattumne. Naattanne. Kaisa recording naattaa.